Hello again, trigonometers, or pre-calc students, pre-calculators, I guess that would be the thing to call you. I just finished doing a video in which I showed you a couple of examples of ways we use the sum and difference identities, which look like this. And I want to show you some more examples of other ways in which we use them or other problems that you can do with your sum and difference identities. Okay, the most important thing, honestly, to remember in all of these is that these formulas exist. Not to just look at sine of something plus something and say, oh, that's like distributive property. I just do sine of A plus sine of B. No, I don't. Okay, so here we go. Next question I want to look at here is I want to look at, and I am going through the test review for Unit 4 test for my pre-calc students right now. So this is a problem from the test review, not necessarily in the same order they see it in on their page. So here's the first one, cosine of 285. The first thing that comes into mind here, again, when we have a number like this that is not a number we're used to seeing on the unit circle, we can say, hey, is there any way I could split this up somehow into two numbers that I am used to seeing in the unit circle? Because those I know the value of. And usually when you're asked to do this, the way you know you're being asked to do this is you're asked to find the exact value. Because some of you are thinking, why don't you just type that in your calculator? Because that gives me a decimal. And the idea here is I'm supposed to be finding the exact value, which means not rounded to a decimal approximation. So here we go, 285. I can split that into, well, we could split it 270 and 15. Problem with that is 270 is a unit circle value, but 15 is not. Okay, so remember that the goal is to split it into two values that are both unit circle values. We could split it into, how about 315 minus 30? 315 is a number that I'm used to thinking of on the unit circle, and I know where that is and what the values are, and so is 30. So I could do that. Another one that have come to mind right away for you is 240 and 45 and adding them. But since we've done a couple of adding problems in our last video, let's go ahead and do a subtraction. So again, this is not going to be just cosine 315 minus cosine 30. We have to now use the formula that is for cosine and subtraction. So it's going to be cosine of the first number times cosine of the second number plus sine of the first number times sine of the second number. All right, so cosine 315 cosine 30 plus sine 315 sine 30. And now I need to know what those values are. So now I'm going to think about on the unit circle where 315 is, right in the middle of the fourth quadrant. And I go to get there, I go over root 2 over 2 and down root 2 over 2. It's a 45, 45, 90 triangle. And so these are my coordinates. The first one is the cosine of that angle, and the second one is the sine. So this angle is 315 degrees. That would be the same as 7 pi over 4 in radians. All right, next one. Not sure why that's lagging as I move my page. 30 degrees. That's a pretty easy one. It's in the first quadrant. It's the same as pi over 6. Here's the 30 degrees. I go right, square root of 3 over 2, and up 1/2 to get there. It's a 30, 60, 90 triangle. So cosine of that angle is square root of 3 over 2, and sine of that angle is 1/2. And now I'm ready to plug these values right here into this expression. So cosine of 315, that's right here. Cosine of 30 is right here. Plus sine of 315, that's up here. Don't forget that it's negative. And sine of 30 is right here. And we get square root of 6 over 4 minus, because this is going to make a negative, square root of 2 over 4. And again with the square root of 6 and the square root of 2, I'm telling you, it's really common to get those numbers in my answer in some way or another. It could be square root of 6 minus square root of 2. It could be square root of 2 minus square root of 6. It could be square root of 6 plus square root of 2. It's going to be different. You can't just assume those numbers are going to be there because you also could have values of 1 or 0. But it's basically because we're using unit circle values, and these are the numbers. We still see, we keep seeing the same numbers over and over when we're using angles on the unit circle. So we're going to see the same numbers over and over when we're getting our answers here. Next up, let's do something a little different. This one is asking me to complete the identity. It says this. It says complete the identity. And then what it asks for us to complete is this. Now, that's a little bit ambiguous of a question. Complete the identity. Complete how? They really want me to apply sum and difference identities. Okay? There are other ways I could complete this because all it has, an identity is basically just a statement that's always going to be true no matter what x or theta or whatever your variable is. So there are other things I could write there, but they're asking me to apply the sine of a sum formula and simplify it if I can. So a lot of times people will say, well, I don't know what to do here because I don't know what x is. Don't worry about that yet. You'll see that very often it's going to work out. Just like really in anything in math. If you have variables, a lot of times students will look at a problem and say, I don't know how to do this. When all the problem is, the only reason they don't think they know how to do it is because there's variables. If there were numbers there, they would know how to do it, and they know that. So just treat it like what you would do if there were a number there. So if there were a number there, I would just apply first formula, sine of the first number times cosine of the second number plus cosine of the first number times sine of the second number. There we go. So sine of x times cosine of pi over 2 plus cosine of x times sine of pi over 2. Okay? So the next question becomes, is there anything I can simplify here? And yes, I know the cosine of pi over 2, and I know the sine of pi over 2. Remember, pi over 2 on the unit circle is the same as 90 degrees. And my coordinates there are 0, 1. So here's the cosine, and here's the sine. So I'm going to go ahead and fill those in. So this one, the cosine of pi over 2 is 0. So sine of x times 0 plus cosine of x times the sine here is 1. So anything times 0 is just 0. And cosine anything times 1 is just itself. So this basically is just going to be the cosine. And that's what they're asking me to do here. All right. Now let's look at another one where they're actually asking me to verify an identity, because this is something else I can be asked to do. So verify the identity. Sorry, you can't see it. We just did a sine sum. Now let's do cosine. Cosine of x plus pi over 2 equals negative sine of x. Okay, they want me to verify this. Anytime we're verifying identities, we always start with just one side. We don't work with both sides like we do with equations usually. We start with one side, usually the more complicated side or the one that looks like it could be simplified. And a lot of times that's on the left, not always. And basically we simplify it, we apply whatever properties we know, we try and break it down and get it as simple as possible and figure out how we can get from there to here. So I'm just going to start with this. I'm not going to write equals that. Basically, I'm just taking a journey from here to here. I've seen sometimes people say, this is my left-hand side. We're going to start with the left-hand side, and when we get it equal to the right-hand side, we're done. I kind of don't like that because it's not always the left-hand side that you start with. A lot of times it is. It kind of depends on your level of pre-calculus or trig and your teacher. But generally, you want to start with a side that looks maybe more complicated or looks like it could be simplified or like maybe there's a property that you could use and apply. Well, I see that I can use sum and difference properties or sum and difference identities. And it's a sum of a cosine. So I'm going to use this one. So cosine of the first times cosine of the second minus sine of the first, sine of the second. So this is cosine of x cosine of pi over 2 minus sine of x sine of pi over 2. All right, and then I can simplify that some more. And cosine of pi over 2, we just did it a second ago. Remember, pi over 2 is 90 degrees. This is 0, 1, which means this is cosine and this is sine. So this is cosine x times 0 minus sine x times 1, which is negative sine x, which is what we were asked to show that this is the same as. And so we're done. Some people put a check mark here. I kind of like to put a check mark here. I've heard of teachers putting a smiley face here. I actually like either check mark or this. And this is actually sort of a notation we use sometimes in proofs to show, okay, I'm done. I have proven the thing I wanted to prove. All right, that's verifying an identity. Let's go ahead and verify one more identity while we're at it. This time we are being asked to verify the identity sine of 3 pi over 2 minus theta equals negative cosine of theta. If you are feeling good about this, and this is always true in my videos, go ahead and pause it and try for yourself. See if you can get to the same place I'm going to get. Pause it, then come back on, check my work, see if we did the same thing. All right, so this is a sine of a difference. So I'm going to use that property right there. So sine of the first, cosine of the second, minus cosine of the first, sine of the second. So again, I'm ignoring this whole side over here. I'm just starting with this side and saying that equals sine of 3 pi over 2 cosine of theta minus cosine of 3 pi over 2 sine of theta. So let's think about where 3 pi over 2 is. This is half of pi, which is pi over 2. This is 1 whole pi. This is 1.5 pi, which is 3 pi over 2. So the point here is 0, negative 1. This is the cosine. This is the sine. All right, so the sine of 3 pi over 2 is negative 1. And that's times cosine theta minus the cosine at 3 pi over 2 is 0. And that's times sine theta. 0 times anything is just 0. So this whole thing becomes minus 0. So it's irrelevant. So it's just, I had a feeling a cat was going to cross the screen. Negative 1 times cosine of theta, which is where we were asked to go. So we are done. Hope this helps. I've got another couple of examples I'm going to show you in another video.